All right. Hello, everybody, and welcome to July's Western Pennsylvania Mushroom Club meeting. And we're as organized as ever, but all right, I'm just have to shut down one window. But we should be live now. Yes, okay. All right, so apologies for that. Took a little while just to get sorted. Anyway, so this is the July meeting, Western Pennsylvania Mushroom Club. And yeah, I think we're about all set. So I'm going to give a little bit of the introduction that we normally do. And this isn't going to be quite as smooth as I thought it would be, but that's the nature of Zoom meetings and complicated computer setups, but it should still work. All right, so first we have the newsletter that went out, and it covered a number of different events and articles that have been published about the club in Microfile. Had a review of the club. This is the first club they've done a review of. And also in Fungi magazine, again, there was a similar sort of review of the club. Oh, sorry. Microfile was the Allegheny General Hospital research. The poster was published in there. And in Fungi magazine was the review of the club, which is the first installment of a series of Mycological Societies forums. And other things the newsletter covered was out and about virtually with West Pennsylvania Mushroom Club and Earth Week. Garrett Taylor led a virtual walk for the Allegheny National Pilgrimage in New York's Allegheny State Park. And that's also online. When there's links to these on the BioBlitz. Hopefully many of you are playing bingo. And this is part of iNaturalist. And I'm looking for my bingo card here. And I am doing quite well, but I don't have a bingo. We have a number of winners here. At least 3 people. I think Carson Gross has won twice now. I have quite a few ticked off, but I don't have any lines. So I'm just going for the full house at this point. And I'm having difficulties. It's basically very dry out, though it did rain a little bit today, hopefully where you live too. But I'm not really finding a lot of mushrooms at the moment. It wasn't too bad, but not as many as I would like. So we had a couple of secret walks. I did a walk in Allegheny County, and this was turned out to be Deer Lakes. We found quite a variety of mushrooms, but only 1 or 2 specimens of each walk. So that was nice. And we did it socially distanced with masks at the beginning and the end. Really just try and obey by the current guidelines for gatherings with less than 25 people outside, and that was pretty successful. And we did a similar thing on Sunday. Jerry Sapp organized a walk, and it was in Lawrence County. It turned out to be McConnell's Mills, and again it was a walk with social distancing and so on. The group split into 2, going north and south of the Slippery Rock Creek, and a larger variety of mushrooms was found, but still not a huge number of any one particular species. But there was some interesting stuff there. And the species list for that walk at McConnell's Mills should be published later this week. We have some upcoming events. There's a walk with Allegheny Land Trust with Cara Culture. That's sold out already. And there's another walk with Allegheny Land Trust at Devil's Hollow with Fluff Burger. And you can register for these walks online. There's a link in the event section of our website. And hopefully we're going to organize some more socially distanced walks in the near future. We have a couple of other walks normally when we have the foray in September. So we have a secret walk in Clarion County. You can sign up for that. We're actually doing probably 2 walks there. So we can accept 50 people at 2 different locations. So if you want to take the Friday off and go hunting for mushrooms in quite a special site, I recommend signing up for that. And on the Saturday, we'll be doing some secret walks at a location we know quite well. And again, we'll set multiple, or you can sign up, many people can sign up, there'll be more than 50 places. But again, each individual walk will be less than 25 people. And of course, we play these things by ear. So if, for example, the guidelines change and they say only 10 people can gather together, then we will have to follow those rules and guidelines. And in the afternoon of Saturday, September the 12th, we will have a virtual presentation. So it will be a YouTube presentation like this, and that will be broadcast at 1 p.m. The Science Sunday that we were going to do on the Sunday, the September the 13th, we've basically postponed that. It's a little harder to get together in a room and really sort of do some hands-on education and so on. And I think broadcasting someone dissecting a mushroom and looking at spores on the microscope isn't really going to do it. So yes, we'll do Science Sunday next year. So the Saturday, September the 12th, will be Longlet Woon interview, and she wrote a book quite recently, The Way Through the Woods on Mushrooms on Morning. She currently lives in Norway, and this is quite an interesting book. I recommend going out and reading it, borrowing it from the library, whatever. She's pictured here with Gary Linkoff, who she met a number of times at NAMA conferences. We have the membership report from Jim Wosick. Last year, by the end of 2019, we had 1,008 members. We're unlikely to reach that number for obvious reasons this year, but we're still doing spectacularly well with 763 members spread over 427 households. So we'd like to thank you for your membership and supporting our activities. And we're really hoping to sort of continue sharing things and providing more content and activities and so on. Next month's speaker on August the 18th will be Beliefs with Scott Pavelli. And again, this will be a YouTube meeting unless things change radically. So in the same sort of format as this. And tonight we have 3 speakers. We have Judy, who will be giving a talk on polypores. Lamont, who will be giving a talk on slime molds. And we have Danielle, who will be giving a talk on the crack cap polypore, which is a research project that he's initiated using iNaturalist and looking at sort of metadata about the polypores. And Danielle is also a recent recipient of a Western Pennsylvania Mushroom Club scholarship on a slightly different project. And I'm sure we'll be hearing about that in the future. So without further ado, I'm going to switch over and we're going to have our first speaker, which will be Judy. So I need Judy to share her screen and turn on the microphone and speakers. All right. So I can see the screen and Judy, please take it away.
Here we go. Welcome to the wonderful world of polypores and crust fungi. I have been fascinated by these since I went to my first foray, and Gary Linkoff was encouraging us to study the polypores and crusts because they're available all year round. You don't have to just go out during chanterelle, morel, and sheepshead seasons. And so he challenged us to start studying the polypores that were less common and the crusts. So I took him up on his challenge. After all, how many mushrooms can there possibly be in the winter? And so between the beginning and the end of winter, I found over 120 species of mushrooms. And he was right, and I was hooked. And I've been studying mushrooms ever since. Here's the obligatory warning. We all know the drill. Don't ever eat a mushroom you're not absolutely sure of. And if you're starting with a species you haven't had before, you know it's supposed to be edible, still just start with a little small piece the first time to test to see how your body reacts to it. It's a lot like strawberries and peanuts are perfectly fine food, but they don't agree with everybody. And I've tried to go through some of the polypores and crusts that have other uses. And I'm not a doctor. I'm not giving medical advice. I'm just passing along some of the folk wisdom that goes along with some of these mushrooms. I thought we'd start off with what is a polypore? What makes it special? And so poly just means many, and pore, like the pores in your skin, are small holes or openings. And so in this case, these fungi will deposit their spores through these little openings. So you can tell a polypore by the little dots on the underside, except they're not always dots. Sometimes they're angular, sometimes they're hexagonal, sometimes they even elongate and look like they're teeth. And the funny thing about polypores is, while originally they did stick them in the polypore species genus, they discovered later that with the DNA testing that polypores are on many different mushroom families, and the same thing is true of crusts. I've always wondered, why are false turkey tails considered crusts when they look just like a turkey tail, which is a polypore? But according to Michael Quo, any of the wood decomposing mushrooms that have a smooth or pimpled or wrinkled surface instead of pores or teeth makes it a crust. So now I have my answer. False turkey tails are crusts. Without fungi, like polypores and crusts and some of the guild mushrooms to break down the tissues in the fallen trees, imagine us drowning in this sea of dead wood. Just generations of trees piled up. We couldn't go anywhere. Fortunately, the mushrooms are able to take those nutrients that are stored and locked away in that tree trunk or branch and break it down into usable nutrients so the next generation can grow up in that area. And you wonder, how on earth can a tiny little fungi recycle an entire tree? That doesn't seem likely. But the mushroom part that we can see is like the fruit of the fungi. The real fungi is living in the soil, or in this case, in the wood. And it puts out little threads called hyphae. And a group of the hyphae is called mycelium. And that mycelium is going to secrete enzymes that can break down the cell walls in the wood and release the nutrients to feed the fungi. After all, it needs to get something out of this, and then return the rest of the nutrients back to the soil. Sometimes you're going to see this as brown rot. You ever go out in the woods and you see a fallen tree and it looks like little brown cubes all stacked together? That's because the brown lignin has been left behind, and this particular fungi ate the cellulose and left this blocky framework called lignin back. And just as an aside, for those of you who like to do primitive fire making, this brown rotted wood will hold a spark, but it doesn't break out into flames. So if you're trying to carry a coal along with you, brown rotted wood is something to consider. So some of these brown rot fungi also will attack the living trees, not just decompose the dead wood. They're parasitic. And so the one we're all familiar with is chicken of the woods, sulfur shelf. And it is going to be orange on the top when it's fresh and have a yellow pore surface. You can see the edge of it is yellow. There is another variety that's common here, cincinnatus. That's the white chicken of the woods. And it also is orange at the top, but it's going to have a white growing margin and a white pore surface. And it usually is growing near the on the ground, where it's actually coming up from the roots or from the wood that's under the soil. So you'll often see it beside the tree, as opposed to the yellow version, which is going to usually be up on the tree. And there is another version that grows on conifers, especially hemlock. And all of them are edible, but like strawberries, they don't necessarily agree with everybody. So always test a section before you eat it. The next one to the right is the Dyer's Polypore, and it likes conifers, especially white pine, red pine, and it will come up. Those things can get pretty large. I've seen them up to almost a foot across. Usually they're about 6 inches or so. And whenever it's young and it's mostly in the yellows, you'll notice on the outside margin is yellows. That's when you're going to get your best yellow dye. It's why it's called the Dyer's Polypore. And your best yellows are going to be when the cap is mostly yellow. It will also make oranges and browns. As the mushroom matures, it gets older, it gets less fresh. It's not going to make good yellows or oranges anymore. It'll make a weak brown dye at the end. Dry rot. This is a crust fungi that will also attack living wood. And the birch polypore is in the bottom right. That one has a lot of uses, and we'll talk about that in a minute. Another brown rot polypore that is edible is the cauliflower mushroom, and it loves oaks. And sometimes you'll find it at the base of living trees as well. We have 2 species here. The one that you see on the left is crispa, and you'll notice it looks like an endive. It's all frilly. The branches are short. They're all of a uniform color. And the other one, spatulata, is more of a fan shape. It's curvy and it looks like a fan, has a common base, and you'll see some zonation in the color. Both of them are edible when fresh. I've eaten both of them. We talked about brown rot. Some of these cause white rot, and this is the opposite. This is whenever the fungi digest the lignin and leaves behind the stringy cellulose. And you can see that the resulting wood looks very stringy and very white. And again, for those primitive fire making people, this wood can easily catch a spark and go poof into flames. So even in wet weather, you might be able to dig into one of these white rotted wood and logs and some of the fiber in the middle may still be dry, and you might be able to get your fire started. Other white rot fungi that you're familiar with, the one on the left is the true turkey tail, Trametes versicolor. And this one is going to be on dead wood. You can be zoned in shades of blues, sort of a grayish blue, or in shades of brown. And the other one that's on the right is the artist conch, Ganoderma applanatum. And it can also attack living trees. And you can use both of these species for medicinal teas. You can take the caps, chop them into small pieces, use about an ounce of dry fungi to a pint of water, simmer it for about 2 hours, add more water as needed if it starts to boil away. And on the Ganoderma, you can see that because it's a perennial, it's multi-years, you don't have to use the whole thing. You can use the outer, more tender part on the outside and chop that up. And there are a couple of different ways to prepare your medicinal mushrooms. You could make a tea. You could take that tea and add it to your lemonade. You could make what's called a tincture. A tincture takes those bitter alcohol-soluble compounds known as the triterpenes. And these have properties that are anti-inflammatory, antimicrobial, some cases anti-cancer properties. So you could take a jar, fill it about half full of thinly sliced dried fungi, or if you're using the fresh stuff, fill it up 2/3 or not quite full, and then cover it with an 80 proof vodka and allow it to age 6 to 8 weeks. Shake it daily. Again, if you don't shake it daily, the world doesn't end. If you forget it for several months, the world doesn't end. They still work fine. Strain it afterwards, seal it in a clean jar. I have just plain left it on the mushroom and had it there for several years and still had them be perfectly fine. You can also do what's called a decoction. This takes the water-soluble polysaccharides that are long-chain carbohydrates, especially the beta-glucans, and these help modulate your immune response. To extract these guys, it's like making the tea, only it's a really strong tea. Put a cup of chopped fungi, and you can use the fungi that you strained out of the tincture per quart of water into a non-reactive pot. Non-reactive is going to be stainless steel, Pyrex glass, or enamelware, because you don't want it to react with the metals in the pot. It will combine with the iron in an iron pot or with the aluminum, and you don't want it to do that. So we're going to use a non-reactive pot and let it simmer for at least 2 hours. Some people will put it in a crock pot and leave it there overnight. They allow the liquid to reduce by about half, so you're not keeping it at the same level. So if you start off with a pint, you want it to get down to a cup. Whenever you're using fresh mushrooms, you may want to reduce it a little further, simply because fresh mushrooms have so much water in them. Well, maybe not as much this year when it's so dry. So we might reduce that a little more. The reason for this is that if you're making what's called a double extraction, where you take the tincture that you started off with and going to take what's left from your decoction and mix them together, what happens is the alcohol in the tincture will help preserve the liquids in the decoction. And so it is an advantage to make sure that you don't end up with it too watery, or you're not going to have enough alcohol to be able to protect the ingredients. And so there's always this argument, which one do you do first? If you do the decoction first and then take the leftover mushrooms and make the tincture, you have the advantage of starting off with cooked mushrooms, which is a good thing. The disadvantage is that decoction isn't going to keep. So some people do that first, and then they'll keep the decoction in the freezer until after the tincture's done, and then thaw out the decoction and mix them together. There seem to be done both ways, and it seems to work either way. So we talked about the artist conch. The artist conch is called artist conch because if you turn it over, whenever you scratch the back, it makes a permanent dark bruising. And so people use it as an artist canvas and do drawings. And also the pore surface has been used for a hearth board. If you're doing fire making, they'll use that to put your stick in to do your fire by friction. But there are other Ganoderma species we have here that are very useful. Several species look like somebody lacquered top of it, which is why they're called varnish shelf. There's a hemlock version called Tsugae, because the host tree, the eastern hemlock, is Tsuga canadensis. There's a hardwood version that has a stem, Curtisii, used to be called the Reishi lucidum. Now we say that it's Curtisii that we have here. And if it doesn't have a stem, it's sessile, which just means without a stem. It's always nice to know that some of those Latin endings, because they tell you which one you're looking at. So you can take that nice tender growing age, dice it and cook it, or you can take the whole cap, cut it up and dry it for tea or powder it, save it for the winter. But the one everybody asks about is this a turkey tail? And Michael Kuo has a wonderful true turkey tail test. Look under his Trametes Versicolor on the mushroomexpert.com website. This is the true turkey tail that you see here. And this was a wild one because I assumed that those color changes in the caps were probably caused by the soil, minerals, etc. But if you take a look at these, you'll see that the blue grays that are on the top are intergrowing with the browns and pale colors. And there they are growing together. And I doubt there was a whole lot of mineral difference in that inch. So obviously we've got some different species, not species, but some different varieties here growing together. So there are other Trametes, Versicolors, the true turkey tail. There are other Trametes that can be confused with it. On the top left is Ochracea, and for the word ochre, which is that sort of a tannish shade. And you'll notice that even though there's a little bit of zonation, they're pretty much colored that same ochre color throughout. The one on the top right is called the downy turkey tail, pubescens, and it's hairy, but it's all white. The one on the bottom left is also hairy, called the hairy turkey tail, and that's Hirsuta. And you'll notice it has zones, but they're only in tan and white. The thing that these are all gonna have in common is if you take a look right here, this is the pore surface. It has a fairly small pores and it's nice and white. So if it's going to be a true turkey tail, you're going to turn it over. It's going to have a white pore surface and fairly small round pores. You're going to want to use this turkey tail for tea whenever it's nice and fresh and white under there. When it starts getting off color, it's going to also get buggy and you're not going to want to use it then. Look this guy over here on the right. This is the underside of the false turkey tail. It's a Sterium ostrea. And the undersurface is beige to orangish, but you notice it is perfectly smooth. There's no pores. It's not white. Once you turn it over, there's no question. And we've got a bunch of other ones that sort of look like the turkey tail until you turn it over. The one on the left is the smoky polypore, and it can also be sort of lightly zoned, but turn it over, it's gray underneath. It is not white. And the mossy maize polypore that's on the right, those caps are definitely zoned. If you looked at the top, you'd say, oh yeah, turkey tail, no question, until you turn it over. And then you see this funny maze-like pore surface. We've got another one at the top left. You take a look, we've got brown caps, white growing margin, growing on a branch. Okay, we got another turkey tail. But it's not. Turn it over. This is crimpgill, and it looks like flour underneath with all this delicate veining, all swirled. It is not a turkey tail. It's amazing how many things aren't turkey tails. This is the splitgill that's somewhat similar to the crimpgill in that it's got a white cap, I mean, a white surface. This one also has a white cap on the top and these amazing folds. The funniest thing about this mushroom is it takes those folds and opens and closes them to protect where the spores come out. This mushroom is actually a medicinal mushroom. They are being studied for antiviral, immune system boosting, anti-cancer. In the tropics, they actually eat this when it's young. They dry it because it's sturdy enough to hold up that tropic heat. And they actually cook it in a liquid first and serve it. This is another one with a white cap on the top, but turn it over. There is no white pore surface underneath. Instead, it's sort of pinkish beige. And the funniest thing about this guy is that the place where the spore tubes are going to be, the hymenium, it stretches. You can actually peel it off and stretch it, which is why it's called the bubblegum fungus or the rubber band fungus. Here's those false turkey tails. The one on the upper left looks like a clam shell or an oyster shell, which explains why it's called ostrea. It means oyster-like, and you know what? They're right. The one on the right is complicatum, and this one looks like a whole bunch of little cornflakes, and it's also called crowded parchment. The one on the bottom left looks like all the other stereums. They all have smooth surfaces on the backside, and the top is sort of zoned, except if you take the underside and scratch it on this one, it actually leaks out this red fluid, which is why it's called the bleeding parchment. And the one on the right is especially fuzzy caps. Not surprisingly, it's the hairy parchment. They're all stereums. There are other fungi that sort of at a distance look like turkey tails. You can get some zoning on the violet tooth polypore, but when you turn it over, again, we're not getting those white pore surface with the little dots. Instead, this pore surface is going to be colored somewhere between violet and off-white. The funny thing about this one is, if you take a look with a magnifying glass at the edge of the top of the cap, you find these little tiny, look like little black stick pins or matchsticks on the top. And there it is. It's a Phaeocalicium, and it's called fairy pins, and it only grows on the trichaptum caps. You can see why it's called the violet tooth polypore. It can be, when it's fresh, a lovely violet color, but it very quickly, the pores start to elongate and eventually decay into what looks like teeth. And we'll get more of a reddish brown color and eventually get to off-white teeth. So there's another one with teeth that we see. This is the milky white polypore. Very common here. White caps with white teeth. And that distinguishes it from some of the others. We have other white rot fungi that will attack living trees. Remember, we did the brown rot fungi that did that. Well, there's some white rot fungi that's also parasitic. These guys all love oaks. The one on the upper left is this funny amorphous looking lumps all down near the bottom of the trunk and around the roots. And if you see the warded oak bracket, you know that the roots are already damaged. By the time it's starting to fruit, the damage is done. The one on the upper right is the Berkeley's polypore. It attacks the heartwood of roots and lower trunk. You're going to recognize this as a big polypore. We'll talk about more about that later. The reishi we already talked about. It will also grow on living trees. And the bottom right, the black staining polypore. Those all sort of, the black staining and the Berkeley's, remind us of the maitake or sheep's head mushroom. This is a really popular edible fall fungi. And the nice thing is that when you find it, you find a lot of it because they can be as big as a bushel basket. And they'll grow around the trunk of a living mature oak tree or an oak stump. So if you're going to go looking for this, look for the big oak trees or the big oak stumps. It's ready to eat when the underside pore surface is still nice and pristine and white. You can see in the upper right, the back of that is nice and white. And what you're going to want to do is just take this and pull apart each one of those little leaflets. They look like leaflets. Here's a closer picture of it. And each one of these little branch sections, pull them apart because the critters love to hide in all those nooks and crannies. But if you pull it apart a little leaflet at a time, it makes it very easy to make sure all your pieces are clean. Then all you need to do is chop them to the size you want them to be and put them in your dehydrator and to dry them for the winter. Or you can braise them first and then saute them and then put that in the freezer. I like to put it in 1 cup portions, and that way, depending on whatever the recipe calls for, I can spin a cup at a time. The other things that you can confuse with it, we talked about the Berkeley's Polypore. Berkeley's is on the top left, and the caps are large, they're thick, and the way to be sure what it is turn it over. The pores can be very angular. It's going to be out from now until September. The one on the bottom is the black staining Polypore, and it is a summer fruiting fungi. It looks a lot like the Mycologist, the sheep's head, Griffula frondosa, but instead, this one is in the summer. So if you find something that looks like a sheep's head, but it's in the summer, it's probably this black staining Polypore. And the way to tell it easily is to bruise one of the little branch sections, the leaflets, if you will. It'll take maybe as much as 20 minutes for it to start turning black. It'll turn black around the edges and continue to bruise blacker. And the real Mycologist does not do that. So both the Berkeley's and the black staining Polypore are edible. Again, test it first to see if it agrees with you. The black staining one doesn't agree with everybody, and it can turn pretty black in the pot too. So how about a really funny cheesy fungi? These are the cheese fungi. They get so squishy you can actually squeeze liquid from it when it's fresh and when we've actually had rain, which is helpful. The name actually means with a cheesy texture. There's actually a couple of other ones that look similar. There's a blue cheese and a green cheese. Each of them, when they bruise, the one bruises blue, the other one bruises greenish, makes it a way to tell it. The guy on the bottom left is not an orange one to go with the blues and the greens and the white. Instead, it's actually hosting another fungi. It's got a hypomyces on it, the orange Polypore mold, and that's a relative of the mold that causes the lobster mushrooms. So not all polypores are going to be found on the wood. Some of them are going to have a relationship with trees, but they're actually going to be coming up out of the soil. The one on the left is an albatrollus. They like conifer woods. And the white, the tan cap of the relative one, the sheep, the forest lamb or sheep mushroom, gets to be cracked, but it is an edible one. The one on the right is called the earth fan, and they have a very dry texture. It's almost like somebody made it out of a very thin wood or a cardboard. But it does come up out of the soil. You can get all sorts of wonderful byproducts. Besides the fact that these trees are doing a decomposition for us, they do a wonderful job of providing stuff for us. So this is the birch Polypore seen from the underneath. They've used it as a razor strop instead of a leather. They've also sliced it thin and used it as field bandages. And I have actually done that. That extra chemicals in there really do seem to help. So maybe you heard a while back when they found the body of Otzi the Iceman. They figured he'd been frozen into this glacier for 5,000 years. And when they found him, he had 2 different kinds of fungi with him. One of them was that birch Polypore we just talked about, which also has medicinal uses. And he also had tinder from the tinder bracket, which is another fungi, sort of looks like the artist fungi, except it grows down like a hoof. So it's also called the hoof fungi. And every year it adds a new layer, so the hoof keeps getting longer and longer. But if you're going to use this for fire making or felt, you actually want the young ones, because you're going to have to peel that outer layer off, and this stuff is hard as rock. So it's easier to do with a younger one. Very slowly, laboriously cut away that outer layer. And then you're also going to cut away the tube layer, and there's going to be a thin brown layer in between. That layer, they're going to boil for 24 hours and then pound it with a wooden mallet, and they're going to boil it and pound it and boil it and pound it. And when they're done, they're going to have the very best spark catcher for fire starting. And they even have used it for making felt hats. Chaga, used at least 500 years in Russia, supposed to have a whole bunch of wonderful effects: anti-cancer, reduces blood sugar, improves the memory, anti-clotting. It's amazing. It sounds like the wonder drug. A lot of this, because these trees grow on birch, a lot of these properties come from the betulinic acid. Do be aware that there is also a lot of, just flew out of my head, the acid that is oxalic acid, that is going to be a problem, especially if you're going to have kidney stone, propensity for kidney stones. You may not want to do a lot of chaga. So to make this tea, you're going to get that black little mass that comes out of the tree, called a sclerosia, into 1-inch chunks or smaller. Put a handful of the chunks into your non-reactive pot. Remember, stainless steel, enamelware, Pyrex. Cover with a quart of water, simmer until the water becomes reddish brown, maybe about an hour, until the water is the right color. You can add more water if necessary. Strain out the chunks, and you can put those chunks in the refrigerator and reuse them again on another day. They'll keep for a couple of days, and enjoy your tea. And be careful, because it can interact, because it does have anti-diabetic and blood thinning capabilities. If you're taking drugs for that, be careful, because you may be double dosing and not know it. So we've got some more edible polypores. On the right, you'll see dryad saddle, sometimes called pheasant back because of the pattern of the scales, looks like pheasant feathers. And the also called morel hunter's consolation, because it fruits the same time as the morel harvest, and at least you get to take home something you can eat. If you're going to eat it, look for young specimens that still have small pores. They'll have sort of a cucumbery, some people say watermelon rind smell to it. But when it's ready to eat and it's still going to be chewable, it's still going to have very small pores. If you see one with big pores on it, don't bother with it. And don't cook it in a method that's going to make it dry out. Fry it over a high heat or something that's going to make it dry out. That's not going to help its edibility any. The guy on the bottom left is the beefsteak polypore, also called ox tongue, and it truly does look like a piece of meat. It's Fistulina hepatica. Hepatica means liver, and it truly looks like a piece of liver. You cut it open, and it looks like a piece of meat. It really does have a liver texture and look to it. Not all fungi are edible. Looks like my picture of the Hapalopolis has disappeared. This is we thought that there weren't any toxic polypores, but this guy, who obviously is hiding, Hapalopolis nigilans, is sort of an orangish, nondescript looking fungi, grows on dead trees. But if you put a little bit of potassium hydroxide, KOH, on it, it immediately turns purple. It dyes wool purple. But it has a really high concentration of polyporic acid that's a neurotoxic, and you don't want to eat it. So some of the polypores actually come with stems. They're not all on a shelf fungi on the side of a tree. Some of them actually come off with stems. On the left-hand side is the winter polypore, Polyporus brumalis. It likes beech and cherry. And you notice how the edge rolls over. The guy on the bottom left is the spring polypore, Arcularius. And the cap edge has little tiny hairs on it. And it prefers oaks. You're going to find that in the morel season. The guy on the right is the hexagonal pored polypore, and one look at those pores tells you why. And it is a welcome sight that says it's springtime. The orangish cap is going to fade to white. Sometimes it has stems, sometimes it doesn't. These guys are two other polypores that are really distinctive. The one on the right is this brilliant red-orange cinnabar red polypore. It especially likes cherry, birch, and beech. Usually I find it on dead cherry. And the cap color fades with age, but if you flip it over, usually those pores have kept that intense color. Makes a really pale orange dye for wool, but it is a gorgeous one. Some people even use it for jewelry. The one on the left is the bay or the black-footed polypore. This thing can get huge. I've seen them over 8 inches across, 12 inches across. They like cooler weather, and you're going to find this on the really decayed logs. They'll have long stems and they're black at the base, and you'll notice as these age, the center of the cap keeps getting darker and darker. Here's another funny polypore. This is called Sweet Knot. And this guy makes this hard mass, looks like overlapping scales. You find it because of the odor. Not all of them have a strong scent, but some of them do. And it's sort of a honeysuckle flower scent. And they would actually carry a little piece in their pocket as a freshener for the body, especially during the times when people weren't bathing. Or they'd put them in the home to sweeten up the home. Who would ever think of fungi as an air freshener? So these guys are sort of confusing. Two of them because they look alike. The guy on the top left and the bottom left both make these circular caps on small branches. The way to tell them apart is, again, flip them over. The guy on the top looks like gills. And so it is a gilled polypore. One on the bottom is the thin maize polypore. If you turn it over, it has a maize sort of pattern on the back. If you notice in the center of that picture, you've got that brown bruising. It bruises really easily, sort of a reddish brown. Now, you'd think the thin maize and the thick maize would look an awful lot alike, but in reality, the thin maize is a very thin mushroom, where the thick maize is actually really thick, and the gills are a lot wider. There's the crack cap that we're going to hear more about, so we'll just pass by that one. Here's the world's smallest polypore. This little guy is absolutely minuscule, but it's fun to find something different. Then we've got some interesting crusts. These are phlebias. This is a very thin, in the upper left, a very thin, wrinkly surface on the back. All of these have sort of wrinkly backs. This is the trembling Mycologist. Below is the scarlet wax crust. You can't miss this brilliant red crust with sort of a yellowish edge. On the bottom right is the coral pink Mycologist. They're called Mycologist because that used to be a botanic. Its genus name is changed. And you're always going to find these on a false turkey tail. Crust can come in all shapes and colors. It is amazing how many different styles. We've got black crust. These two look an awful lot alike, but the one on the left looks like somebody inflated it. This is carbon cushion or brittle cinder, where the one on the right is smooth to start with, and then it cracks as it ages. Looks like burnt wood. This is the common tar crust. You can also have little ball shaped. Carbon balls can get as big as 1 inch across, whereas these little tiny rosalinias might be less than 1/8 of an inch. The crust can come flat as well. The one on the left, the hypoxylon canker of oak, is white, but you'll see little black squiggles like somebody's been drawing in it. Makes it very distinctive. The one underneath it is the giraffe spots. And it really does look like spots with the white edge around it. The one on the bottom right is the elder whitewash. Looks like somebody took a whitewash brush and just lightly touched. Some of these are tooth crusts. We've got one on the left. This is the Regulomyces, the Asian beauty that has spread across the United States. amazingly fast. It didn't used to be here, and poof, it's taking over. The one on the right is the toothed oak crust. You'll find this on almost every hike on a brown, as a brown crust on an oak branch. We've got on the bottom left the spreading ochre crust, and on the bottom right a spongipellus with the teeth. Sort of looks like it's going to be a milky white polypore, but it's all flattened. And here is my last one. This is my holy grail fungi, the cobalt crust. Whenever I was on my first foray, Gary Linkoff encouraged us to start turning over the logs and twigs around us, and a person near me picked up this nondescript dead branch, turned it over, and this glorious blue, brilliant blue crust was under there. And Gary was thrilled with it. I was thrilled with it. And I know it grows locally because I saw it there, but I have yet to find it for myself. I am still looking. And isn't it wonderful to still have more mushrooms to look for? And by the way, don't forget when you turn the logs over to check for them, turn them back when you're done. Thank you.
Okay, well, thank you, Judy. I do have just one question for you here. Do you ever use violet tooth polypore for dyeing?
That is a really good question. So far, I haven't gotten any color from it, but I have yet to try the really young specimens when it still has violet. So I'll keep you posted on that one.
Okay. Well, without further ado, well, thank you again, Judy. And we're going to go to Lamont, and he's going to be giving a presentation on slime molds.
Okay, this is just aimed at giving you a small taste for one of my passions. So the myxomycetes, or the more commonly referred to as the slime molds. So they are in fact not fungi. It's kind of a historical accident that mycologists are the people that study them. They produce spores, as do fungi, but that's about as close as they get. They're in a whole different kingdom, protozoa. And all of them have a motile stage, a stage where they move around. And you can see in this image, this plasmodium has been streaming across the rock and it's heading upward. These things can actually solve mazes. You put food at the final destination in the maze, it'll explore the whole maze, and once it finds the food, it pulls everybody back and streams them to the food source. So they're really quite remarkable. They use a protein similar to myosin that we use to move our muscles. So. Okay, and I'm sure you've seen this. I chose this picture because it gives you a good illustration of how they can be very difficult to spot. You'll see these white stripes along the wood. But, and this, we find this slime mold more than any other in southwestern Pennsylvania. But it's worth getting up close. It has two forms. One of the forms is on the left here. It's a picture by Richard that shows these little rosettes. And these coral slime molds are the only ones that produce their spores on the outside of their fruiting body. So on the right, you can see these individual bits. They're maybe 0.5 millimeter to 1 millimeter long and somewhat translucent. And if you look closely, you can see a kind of pebbling, and that's the spore-bearing stalks. So Serratiomixa fruticulosa, and the one on the left, Serratiomixa fruticulosa varporoides, or some people call it a separate species. But I've seen poroides and fruticulosa in the same fruiting, just kind of continuously. So I think there's something environmental that triggers one or the other form. Okay, this one's going to be familiar to people. The Fulgoseptica, or the dog vomit, or I prefer scrambled egg slime mold. It's this yellow mass. This one also moves. You can see in the lower right that this slime mold has been moving upward in the picture before it formed its fruiting body. This one's farmed commercially in Mexico, and it tastes like broccoli. I've only had it raw. I've never been able to collect enough of it to try cooking it. But it is perfectly safe to eat. There really aren't lookalikes. Now, when it's in the state that you see in the right, where the inside is brown and the outside is kind of crusty, it is no longer palatable. It has a rather disagreeable flavor at that point. But when it's fresh and yellow and fluffy all the way through, great snack. All right, now this one is a close relative that I've only seen a few times, Fulgo candida, the white dog vomit slime mold. If that doesn't get your appetite going, I don't know what will. This one tastes like cucumber. It has a couple of lookalikes, both safe to sample. I wouldn't eat large quantities. Oh, notice again the trailing edge, that this slime mold is moving upward in the picture. Yeah, Briffeldia maxima, or the tapioca slime mold, does not taste like cucumber. I don't know how to describe its flavor, but it's not familiar. And then Mucilago crustacea, which is another yellow blob, or another white blob, sorry. And also doesn't taste like cucumber. All right, this one's a really fun one to find. This was both photos are from the Western Pennsylvania Club. The one on the right is mine, and I didn't put the name on the left one. All right, anyway, this is just really beautiful when you find it, and you can spot it. You can see the moss here to give you an idea of scale. This tends to be bigger than some of the others. This was an orange variety of tubulifera that we found. I was never able to put a species on it, but they're very pretty. All right, so these are hemitrichias. They're these little lollipops, red lollipops on a short stem. Those lollipops are maybe 1.5, 2 millimeters across, maybe 3 millimeters tall. And you know, both of these pictures are relatively close up. This one, upper right, is very close. From Eleanor Yarroll, and another Richard photo on the left. When they're in this stage, we can't tell the species, but once they mature, they get all fluffy. And there are two varieties in our area, the chalice slime mold and the club slime mold. These are both hemitrichias. The chalice has this low, flat chalice at the bottom, called the colliculus. And the colliculus for clavata is more club-like. And clavata has a single point of attachment at the bottom of the colliculus, whereas the colliculata collects all the way around. But this can be quite difficult to see. These are, you know, millimeters across. And these are really quite beautiful under the microscope. Unfortunately, I couldn't find my hemitrichia photos, so I got some trichia photos. See these kind of double spiral. These are called elaters. They uncoil and release the spores in the process of uncoiling. This is what the fruiting bodies look like. They're really pretty. They have this little iridescence. The main difference between the trichias and the hemitrichias is the hemitrichias don't have loose ends really. They all tend to connect together in a style called anastomosing. They make a net, whereas the trichia has individual ladders that it's easy to find the beginning and end of each one. Oh. Arceria denudata. This one is another one that's common and popular to find. You'll see these little cotton candy slime molds. They can be brick red to bright red. And again, we're talking 3 or 4 millimeters tall for the entire fruiting body. And these are really nice under the microscope. They have these little ledges all over the ladders, and we have some anastomosing here where things come together into full rings. But they're really beautiful. Yes, enlarged to show texture. Here's another one that's really fun to find. Cribraria cancellata, the raylene slime mold. You kind of have these lantern-like things that look like iron railing work up close. And the little circles are the spores. And you'll see these very thin connecting lines from one rib to the next. It's quite distinctive for this species. And here's another Cribraria. I regret I didn't take a photo of the fruiting body at scale. This is just close up. This is the top of one of those 2 millimeter across. So the total distance here is maybe 1/3 of a millimeter. And it has all of these lovely junctions with the spores all over it. This is Pursoon's slime mold. And then here's another popular one, Stemonitis, the chocolate tube slime molds. There are a bunch of them. You're going to hear Stemonitis fusca, Stemonitis splendens, a couple others. I've been told more than once that you can tell the difference by the ratio of the stem to the upper part of the fruiting body, and I have found that to be really unreliable. So this is a little bit younger. When they start out, they're white and look like insect eggs, and then they extend up into this tied together chocolatey thing, and then they kind of dry out and spread, and you can flick them and get spores to come off. And here's a really up close of Stemonitis fusca, the brown chocolate tube slime mold. Yes, great name. Oh well. The stem up the middle called columella. Columella. There we go. And then we have this fine net on the outside, and you can see the structure holding up that net with these larger stems. Not all of the Stemonitis have these large stems. Some of them have another network inside. Okay, and here are 3 books. Well, 2 books. We'll make sure the published version has the 3rd book as well. George Barron's Mushrooms of Northeast North America is a fun reference to take into the woods. He has lovely photos and engaging descriptions. They're not what I would call scientifically complete, but he has an unusually long section of slime molds, and they're beautifully illustrated, and I love his writing. So And we now have a really good worldwide reference for slime molds. That's 2 volumes set called Le Myxomycetes by Poulenmeyer and Bozonnet. 1 volume is photographs and drawings of microscopic structures, and the other is keys. The keys are in French and then again in English. So they're kind of expensive. I think I paid about $120 for my 2 volume set. So for what you get, it's a really good deal. And the third one was from Stephen Stevenson, who is probably the most prominent slime mold expert in North America. He has a nice small book that is a good starting point for learning slime molds. Okay, thank you for your time.
Thank you, Lamont. So you just have to stop the screen sharing. Perfect. And I don't see any questions there, but I know we're short on time. So yeah, thank you again. And there will be a Zoom meeting after this for anyone else that's interested to ask questions then. And hopefully our speakers will be there and be joining us. So Daniel is next. And he's just brought up his screen there. And so, yeah, please go ahead, Daniel.
All right, there we go. Thank you. And I'll try to make this quick so we can hop on to the Zoom meeting. Jump back. So this will be a slightly different tune than some of the other presentations, maybe that we've typically had. This is a little bit more ecology focused on how the fungi factor into forest ecology. And specifically, this is an observation of a TBD behavioral interaction between a forest fauna, and I've got my theories, and the crack-cap polypore using iNaturalist, which I know many of the club members use. And my contact info is on the bottom of the slide in case you have any questions after. So where did this come from? Actually, part of it was inspired by the club in some sorts and just my interest in the area. And I came across a post while researching the crack-cap polypore, which is extremely common in Western Pennsylvania, given the propensity of black locust trees. And this post was by a naturalist, biologist, David Haskell, and he'd observed something kind of strange. And that was that immediately beneath instances of the crack-cap polypore on the black locust tree, which it almost entirely grows on. You can't say it's endemic to the black locust tree, as there are instances, and I've seen it in the data that I've researched, where it's growing on other trees like oak, for example, but pretty close to endemic to that type of tree. And what he was observing was some scratching behavior, and the cover image is one of them, but this is another one that inspired it from his blog post. You can see this discoloration on the bark, and it's actually been removed or scratched, if you will, directly below the fruiting body. No other signs elsewhere on the tree, so you just have fruiting body, scratches. He had a theory, and it was based on the fact that woodpeckers favor the black locust tree because of the fact of their locust borers. This is why the black locust tree is not large in forestry in the United States any longer, because the locust borers pretty much ruined the stock completely. That being said, the locust borer is also one of the entry points for the fungi to actually infect the tree, if you will, as it is parasitic. So that was interesting, but based on that, knows the woodpeckers are attracted to the beetles. The fungi is there, is providing a little bit of cover. So perhaps they were using it as a rain shelter. I saw this and, well, I had questions. So my curiosity began to grow. Here we go, a biologist reporting that what should be a pretty obvious behavior that they hadn't seen before or didn't really know the answer for. So had anyone reported this? And the answer was no. No reports of bark damage associated with either of these species, either the crack-cap polypore or the black locust. So was it isolated or broad phenomena? So was this just something they were seeing in their local area, a few reports, or was it meaningful? So I started my search, and kind of what inspired me to go down this path was using iNaturalist and looking up crack-cap polypore. I went that way because if you look up black locust trees, you get pictures of leaves, not very helpful. But you look up crack-cap polypore and you have an instance of the fruiting body on the tree. And what I saw very quickly was there were more instances and they were scattered, which indicated something was going on. Also, is the crack-cap polypore associated with any animal behavior whatsoever? Not so much. So some instances here, one on the tree that its host is, the black locust, there are instances of gray squirrels, which we have here in Pennsylvania, marking with a scent marking behavior on the tree, but it's not scratching. It's more of a rubbing behavior, and it causes discoloration. It can look similar, but it's more elongated, not associated with the crack-cap polypore at all. However, there is at least one instance I found of animal interaction with the crack-cap polypore, which if you'll look at most popular literature on this polypore, it's more or less described as useless. No one has identified any particular value of that polypore quite yet, other than for artistic purposes. You can basically draw on the back side of it if you're interested, or use it in a furniture piece, but no associations with other forest fauna or anything for that matter, except for one instance in a book on Malaysia relative to bite marks from squirrels on woody polypores, quote marks. So not necessarily the crack cap, but it at least puts it in the same category of a mammal interacting with the polypore, of a similar polypore, although that is as far as it went. And I have looked quite hard and I've not found any reference that ties the two together. So that with my nature just makes me even more curious about what's going on. So some initial hypotheses, although really light ones, for the first stage of this project. One, I find it hard to believe that the relative position of the bark damage below the fruiting body and the actual Pholinus rubinia, the crack-cap polypore, is coincidental. That seems odd. So I believe that's not coincidental. Looking at the damage that I've seen both in the iNaturalist data, and I've done some quick surveys here in Western Pennsylvania, I have a hard time believing it's a bird, although I won't rule it out. But I think a mammal is likely a culprit. And where I've done my observations has been on Squirrel Hill. So I don't want to jump to conclusions, but a squirrel is potentially quite likely for this behavior. It also ties quite well with the marking behavior of squirrels on similar trees. And based on my initial research, that it wasn't going to be isolated. This likely was something that was broad and just underreported. A few examples here: a local squirrel friend here in Western Pennsylvania, just around my house, and then 2 iNaturalist posts. In fact, one could very well be a club member posted here in Pittsburgh. These aren't the ones that inspired the research. These are ones that I actually looked up this week and are quite new. One of these, you can see quite clearly something's going on directly below the fruiting body of the fungi. And then here as well, something's off, which just makes you more curious as to what's going on. So to accomplish this and kind of quantify the data, I performed a digital field study, and really a behavioral field study of sorts when you're really talking about what we're observing on the tree. This is really just phase 1 of the project, which is quantifying how often this is occurring, and then using that data to try and figure out the what and the why. As you can see, when I started this study, there were over 1,400 observations of the crack-cap polypore, Pholinus rubinia, that were reported. Most are in the United States. So there are a few elsewhere in Europe. There should be more. I believe that's more due to the use of iNaturalist than necessarily species distribution. Sample definition, kind of the next stage. So I would use the data from iNaturalist and go, can I use this in my research? So is the view suitable? You've got a really great view here. Yep, I can see directly underneath and around the fruiting body. Here, not so much. I can only see the top, not a very useful view. So that basically defined my sample, not that there are 1,400, I'll review 300. Very much so that I'll review all 1,400, or now I believe over 1,500, and I will categorize them in this matter. Then I will move on to the analysis. So actually looking at the useful, that checkbox data set, and going, well, hey, is there a marking of any sort? And just categorizing them into the general groups. So for example, stripping behavior, discoloration, until I begin to see any sort of trend or able to pull something out of the data to go, what's going on? You can see here, other things that I was looking for are any marks on the fruiting body itself. This is a suspect mark, to say the least. You then take this data and then, all right, to answer the question, is this isolated? Well, let's look at it geographically. So this is part of the really digital field study element, throwing that into GIS software and really looking at the distribution of data, which I'll show you a little bit later, and using that to kind of size up the field evidence. And then for future work, potentially monitoring, although that's more related to the what is happening than necessarily the mechanism that's causing it. So kind of to jump right to the fun part, some examples of what I saw in the data. The most extreme example, and this isn't on the tree itself, but on the fruiting body, very clearly here, some sign of a biting or chewing behavior on the edge, which is very similar to the reports from Malaysia, although otherwise, not many reports of that behavior in the popular published literature. The stripping behavior. So this is the one that interests me most. And I personally think it's progressive, but you can see the bark has basically been torn up from the tree. And if you were to see this in person, and I encourage you, because this is a very accessible species, go out to the park. You will find an example of this within 15 minutes of walking through any area with black locust. And you can see that the bark basically is pulled up right to the edge, which has some follow-up questions that I've developed based on that. But it's pretty violent looking what's being done to the tree. I should also mention, the weird thing here is the bark of the black locust tree is toxic. There are cows that have eaten the bark of this tree and have died. So if there's a mammal or some other forest fauna interacting, why are they able to interact? Why are they even interested in it? Like that just makes it even more fascinating to me from at least a wildlife standpoint, the mycology aspects aside. Other behavior, and I think this may be an example of progression of what's going on in the tree. You can see this kind of wear. I think the wear is step one, then it leads to the stripping behavior, but I can't quantify that, so it's only a theory at this point. But basically a stripping or abrasion, so less than this, but maybe a step. And then I color enhance this, just change the contrast a bit. There's definitely evidence on the fruiting body that there's an animal, and this matches quite well to the marks of a squirrel in this area at least, interacting with the fruiting body. And the cool thing about that, and if my video works, I've actually got a prop, an example really quick. So this is a small crap-cap polypore. Can't see myself, so I have no idea how this looks. But the cool thing about them is they really provide a great witness mark for this ecological interaction between TBD forest fauna and the fruiting body itself. If I use my fingernail, I don't know if you can see, but it actually marks it quite easily. So that's pretty neat. You've got this witness plate on the tree that you could use in a behavioral study effectively of animals interacting with fungus. So this is what the data looks like so far. This study is not complete. Hopefully later this summer, I'll be able to wrap up at least this first stage. The brown is actually the native habitat of the black locust tree. It's an invasive species, although it's also a native species. It's a strange tree. So it's native to places like, well, right here in Western Pennsylvania, but it's actually spread all over the country, wherever it's capable of growing, which is a quite wide space. The white dots represent the entire data set, and I've hidden a few that are in Europe, for example, but you can see they even go down to the Yucatan Peninsula, and that's of the crack-cap polypore. So at the time I started this, 1,425. Of those, remember that checkbox and the X, 162 have been suitable observations, and then red represents where I've noticed the bark damage. Part of my hope here was actually to use this iNaturalist data to go, is the species something that I can deduce based on the distribution? Probably not, especially when we begin to think of things like a gray squirrel, which have a very wide distribution. Also worth noting, iNaturalist data in this data set goes back to 2006. iNaturalist was born in 2008. That doesn't mean it's invalid. It's photo metadata. It just might have been pulled in and imported when they were first creating the project. So I haven't excluded it. And honestly, unless you're doing a temporal study, does it really matter? No, but it's an interesting point and something you have to keep in mind in terms of future work. So this is just the numbers to give you an idea. Out of 236 total observations, that's the blue, 162 of those were actually usable. So I've got 7 times that to still go through in the current data set. Of 162, 61 exhibited bark damage. So kind of begins to answer the question, is this isolated? Not really. These are distributed all across the United States, as you saw in the last slide. Bark stripping is the dominant behavior, although bite marks, scratching on fungi, and these are independent of the 38 bark stripping in this data set, are also present. So there's interaction, and that's meaningful. That means that the crack-cap polypore has a role of some sort in forest ecology that hasn't really been properly characterized to this point. Last point, the signs that I've seen on the fruiting body, that scratch mark, really tells me that squirrels are there, but it doesn't tell me that the only one's there. So future work, like where does this lead us? One, on the wildlife side of things, what species is responsible? Is there more than one? Don't know yet, have some theories, but that's an open question to be answered. And what I actually find fascinating about this intersection of mycology and ecology, there's a lot of unknowns. There's a lot of basic science questions that are still being answered, which I think provides a great opportunity for others who are interested in research to get involved. I'm an engineer by trade. Now I'm getting back into biology. And this is just kind of an intro project. And I think it's a great example for others who are interested as well. So why are whoever's doing it, why are they doing it? Is it territorial? Is it boredom? A little bit of a joke. Is it madness? Is there some interaction with the spores or something on the fruiting body that are causing animals to just go wild? I don't know, and no one knows for that matter. Is the fungi actually playing a role in bringing the fauna to the site? Maybe. Is it the spores? They obviously fall straight down. You do see discoloration on the tree. And I don't want to say before you see damage because I can't make that connection yet, but I think you can. But you see discoloration first. So perhaps the spores are playing an impact. Maybe it softens the bark. Maybe it actually deactivates the toxins in the bark. Maybe the fruiting body and the hyphae are doing something relative to that. Don't know. Really not something that interacts with the bark of the tree. They really are attracted to the heartwood of the tree. So unlikely, but I'll just put a big question mark there. Another interesting one, are the fauna also playing a part in spore dispersal? So right now, crack-cap polypore, spores fall straight down on the tree, perhaps get blown by the wind. But the beetle, so the boring locust that actually puts holes in the tree, is known to help with the polypores entrance point into a new black locust. So could the fauna interacting with that be doing the same? Quite possibly. Another question, is this really limited to the crack-cap polypore? This, to me, if you're living in Western Pennsylvania, at least, although perhaps anywhere that these tree and fungus pair grow, it seems obvious that you'd notice this. But maybe it's so obvious that we've become blind. It's like seeing weeds, you just ignore them, although they might be something really interesting. So is it possible that this is out there in other shelf fungi? Don't know, but it's definitely something we can look at in iNaturalist. It's a great data set, and it provides a really easy way to begin to try to answer those questions. So then another one, can we just go see the fauna in iNaturalist? Squirrels, maybe, although that's a pretty large data set, but birds. So the original question of woodpeckers, when you take a picture of a woodpecker, it's on a tree. If you see a woodpecker on a tree near a fungus, that might begin to make you go, is there an association? And there might be. So just kind of future study there. And then some more that actually tie back into club members. So what else am I going to be doing here? I'm definitely continuing my digital field studies, if you will. The current data set, I need to complete going through that for the crack-cap polypore. New data sets, so additional woody shelf fungi, other fauna observations, like I mentioned. Temporal trends. So if you go out and you observe a site, You're like, it doesn't see a million crack cap polypore. That's not very interesting. Well, it actually is, because you're adding a data point in time as well as in a geographical position. So you go take a picture of one of these scratch sites. And I want to emphasize, please do not only go take pictures of scratched sites on trees, because that will create a bias in the data. Take pictures of them all. You're adding to a data set over time, which could tell us something about progression. So that's pretty cool. So I encourage, if you see the crack cap polypore, take a picture, upload it. Although you will be very busy because there are a lot of them. So also direct field observations. Everything's being done digitally right now. This study works really well in the world of COVID, but that does lend some potential problems. One, is there a sample bias? That might just skew the statistics. It doesn't really affect investigating the mechanism of what we're seeing going on. But that's kind of what I'm referring to. Don't only take pictures of scratched sites. And also to look at a quantification of bark stripping versus other behaviors. Right now, I am just looking at that behavior for the most part, but to go out in the field, maybe people are only looking at the fungus. It might be better to look at the whole tree. So look at a plot of trees that have crack cap polypore and just begin to size it up in a more controlled scientific way. Finally, and this is a project I'd love to do, not just for crack cap polypore, but for other examples as well, to do a video trap. So really a video time study with a video camera in the field, maybe looking at a site that's already been damaged, because at least in the case of the squirrels that are visiting trees with similar markings, they revisit it over time. So if we see some damage, probably means there's going to be future damage. So a kind of a call to members, if you have a site on protected property where one like myself could place that camera equipment, I'd be really interested. So please reach out, because I don't just want to go put it in a local park because it will disappear. So please let me know if that's possible. And that's it, just 2 acknowledgements here. David George Haskell, who really inspired the project, and then iNaturalist, and hopefully all of you who will be posting on iNaturalist to contribute to this project, and others coming down the pipeline involving citizen science data. So thank you. I'll hand it back to you.
Okay. Thank you, Daniel. Let me see. Oh. All right. So that is pretty much the end of the presentations for today. And I'm hoping that our speakers will join us on the Zoom meeting for the club. So I'm going to exit out of this and stop the YouTube part, and then open up the general Zoom meeting for everybody. You have to be a club member to join that general meeting, and the invite was sent in a recent news blast, probably also talking about newsletter and stuff like that, or secret walks. So anyway, see you in a few minutes.